We're all trying to predict what's going to happen next. But what if we're only looking at one little piece of the puzzle? Today, we're going to talk about an awesome statistical tool that helps us move from a simple guess to a way more accurate prediction, all by seeing the bigger picture. Think about a huge operation like this paper mill. To keep things running smoothly, they've got to predict exactly how many chemicals they need based on a ton of different factors. If they get it wrong, it costs them big time. In pretty much every industry, making good predictions isn't just nice to have, it's absolutely essential for success. And that's the real problem, isn't it? A single data point, like how many miles a truck has to drive, usually isn't enough to predict something as critical as the total travel time. And what you end up with is a blurry, unreliable guess. So let's make this super concrete with a case study from the Butler Trucking Company. They were dealing with this exact same problem. Okay, so take a look at this chart. See how scattered all those dots are? Each one is a single trip. Along the bottom, you've got the miles they traveled, and on the side, how many hours it took. If miles were a perfect predictor, these dots would make a nice, neat line. But they're all over the map. A 100-mile trip might take 7 hours, or it could take almost 10. That's a huge, huge difference. What we're looking at here is a classic example of something called simple linear regression. That's just a fancy way of saying we're trying to predict something using only one factor. And while it's useful sometimes, in this case, well, it's pretty obvious that just knowing the miles isn't telling us the whole story. So, how do we get that blurry picture into focus? Well, we add more information. It's like adding more lenses to our camera, and that's where multiple regression comes into play. All this means is that we start looking at several causes at the same time. So instead of just asking how many miles did they drive, we can also ask, okay, but how many deliveries did they have to make? Each new question, each new variable helps us see things way more clearly. And the process is actually pretty straightforward. We start with that simple one-factor model we had. The managers at Butler Trucking had a hunch that the number of deliveries was a big deal. So you just add that second variable, deliveries, right into the mix. So what actually happens when we add that new factor? Well, the impact of just one extra piece of information is, well, it's pretty dramatic. Okay, here it is, the big reveal. On the left, that's the computer output from our original miles-only model. And on the right, that's our new upgraded model with both miles and the number of deliveries. Just glancing at them, you can already tell some of the numbers look way different. And this slide just lays it out perfectly. That top equation was our best guess before, but the bottom one, it's so much smarter. It gets that every mile adds a little bit of time, and that every single delivery adds almost a whole hour to the trip. It's just a much more complete, much more realistic formula. So the new equation looks more complicated, but how do we actually prove it's better? Luckily for us, statistics has a way of keeping score. I want you to meet R². Honestly, the easiest way to think about it is as a report card for our prediction model. It's a score from 0 to 100% that tells us how much of the variation in travel time our model can actually explain. And obviously, a higher score is a better grade. And will you look at this jump? Our old model, the one with just miles, it scored a 66.4%. I mean, not terrible, but that still leaves a third of the mystery completely unsolved. Our new model, with both miles and deliveries, gets an incredible 90.4%. We basically went from a C+ to a solid A on a report card. Let's just pause on that number, 90.4%. What that means is that by knowing just two things, the distance and the number of stops, we can explain over 90% of why the travel times are different. We've totally replaced a blurry guess with a sharp, reliable prediction. Okay, so our model got a great overall score. But, just like with a good recipe, we need to check our ingredients. Is each variable we added truly making a difference? And this simple little table tells us everything we need to know. The impact column shows us how much each factor changes the travel time. But that last column, the one that asks, is it significant? That's the real key. And we figure that out using something called a p-value. And here's the rule of thumb. It's super simple. A really low p-value, and by low we usually mean less than 0.05, is like a big stamp of approval. It tells you that the variable's effect is the real deal, not just some random chance. As you can see, both miles and deliveries had tiny p-values, which proves they both belong in our model. So we helped Butler Trucking make way better predictions. That's awesome. But the power of this tool goes so far beyond just trucks and deliveries. And that really is the heart of it all. By looking at miles and deliveries, we got a much deeper understanding of what was going on. Multiple regression helps us see those hidden connections that are everywhere in the real world. So let's do a quick recap. Real-world problems have more than one cause, right? Multiple regression is the tool that lets us build models for that complexity. R-squared is our report card. It tells us how good the model is, and p-values make sure every piece of that model is actually important. And believe me, this isn't just something you see in a textbook. This is the exact engine running behind economic forecasting, medical research trying to find risk factors for diseases, and even sports analysts trying to predict which players are going to be stars. It's a fundamental tool for making sense of our complicated world. So we'll leave it there. You now have the basic idea behind a super powerful tool for finding hidden connections and turning those blurry guesses into crystal clear insights. So the only question left is, what complex problem do you want to solve?